international milestones. Forensic chemistry didn't just appear overnight. It grew from humanity's need to seek truth even when justice had failed us. Let's explore the 3 moments that changed everything. Number 1. The Marsh Test in 1836. When science corrected injustice in 1832, a man named John Bodel was hanged for poisoning his grandfather with arsenic, or so everyone thought. Chemist James Marsh was asked to review the case and discovered that arsenic was actually copper leaching from the burial vault's metal lining. Devastated by the wrongful execution, Marsh spent 4 years developing a test so precise it could detect even tiny amounts of arsenic. Here's how it works. Zinc and sulfuric acid react with an arsenic containing sample to produce arsenic gas. When heated, this gas leaves a distinct silver mirror on glass, a signature to no other substance can replicate. Locard's Lab, 1910. The birth of modern forensic. Imagine a lab with just 2 rooms, a single microscope, and a shelf of chemicals, yet this tiny space revolutionized how we solve crimes. Dr. Edmond Locard opened the world's first dedicated forensic lab in Lyon, France, and introduced something revolutionary. Locards didn't just do chemistry. He linked chemical analysis to fingerprints, tool marks, and witnesses' accounts, creating the first system for building cases from physical evidence. His lab notes, which we've translated here, show he matched paint chips from a suspect clothing to a stolen car, proving guilt with scientific certainty. This was the moment forensic science stopped being a collection of tricks and became a discipline. World War II accelerated scientific innovation, and forensic chemistry benefited more than most. In the 1950s, gas chromatography gave us the power to split complex mixture into individual components. The 1960s brought infrared spectroscopy, which let us see the molecular fingerprint of unknown substances. Then, in 1980s, combined these 2 technologies to create GCMS, or the gas chromatography mass spectrometry. This machine is the backbone of modern labs. It can identify everything from heroin to gas with 99.9% accuracy. Our homemade model here shows how it works. Compounds travel through a heated column separated based on their weight and size, then hit a detector that tells us exactly what each one is. Local history. Forensic chemistry in the Philippines. While forensic chemistry was growing in Europe and America, our own story was unfolding, shaped by our colonial past, tropical climate, and unique challenges. Spanish colonial era. Medicina legal and vegetable dyes. Forensic chemistry here began as medicina legal, reserved mostly for cases involving the colonial elite or wealthy landowners. Spanish colonial era. Forensic chemistry here began as medicina legal, reserved mostly for cases involving the colonial elite or wealthy landowners. Spanish physicians used simple but clever tests. They matched purple cabbage to make an indicator that changed color in the presence of poisons, or used lead to acetate to spot arsenic in food and drink. Surviving records from 1887 of a high-profile poisoning case in Sambong. Investigator tested leftover soap using lead acetate, which formed yellow crystals confirming arsenic. This case set a precedent for using science in Philippine courts. American colonial period. Combating smuggling and forgery. When Americans arrived, they faced new challenges: opium smuggling and widespread counterfeiting of pesos and documents. In 1912, the Philippine Constabulary established a chemical section, our first formal forensic unit. Chemists used gravimetric analysis to weight and identify opium derivatives, and develop methods to compare ink samples by the chemical composition. Manila courts show how they match forged land titles to ink bottles seized from the counterfeiting. Post-independence era, from one lab to nationwide network. After independence, we built our capacity from scratch. The NBI's Forensic Science Division was founded in 1966 with just one chemistry lab in Manila, equipped with a single spectrometer donated by the US government. In 1972, we opened our first regional lab in Cebu, serving the Visayas. Then, in 1985, right here in Davao, we opened our Mindanao hub, bringing forensic chemistry closer to the communities that needed it most. For years, our chemists worked with limited equipment, but their dedication set standards we will follow today. Modern era. 1998, President world-class standards in the tropics. The PNP Crime Laboratory was formalized in 1998, and in 2015, we earned accreditation from the International Organization for Standard, or ISO, putting us on par with labs in Europe and America. Today, our Davao lab handles over 1,200 cases every year, from analyzing synthetic drugs to identifying accelerants in arson. We use cutting-edge tools like liquid chromatography mass spectrometry, or LCMS, to detect new designer drugs that didn't exist just a decade ago.
Two principles stand above all others in forensic chemistry. Master them and you understand our purpose. Break them and you destroy the trust that makes our work matter. The Locard exchange principle. Every contact leaves a trace. Edmond Locard said it best: every contact leaves a trace. This isn't just a saying, it's a fundamental law of physics. No matter how careful a criminal is, they cannot avoid transferring material to or from the crime scene. Forensic chemistry as the objective arm of the law. Witnesses do their best, but human memory is fallible. Stress, bias, and time can exchange how people recall events. Forensic chemistry provides something different: quantifiable, repeatable data that doesn't depend on perspective. Let me show you what this means with real local cases. In 2022, a man in Barangay Buhangin claimed he was attacked with acid, but when we analyzed the substance on his skin, our GCMS results match exactly to battery electrolytes from his own damaged motorcycle. The chemistry proved his claim was false, preventing a wrongful arrest. A witness testified she saw a suspect pour something sweat into the victim's drink. Our toxicology test revealed ethylene glycol antifreeze, which has a sweet taste but it fatal in small amount, and our analysis confirmed her account, proving the evidence needed for conviction. Here's what you need to remember. We We do not work for the prosecution or the defense. We work for the truth and we let the chemistry speak for itself. Legal weight, turning science into evidence. Science without legal rigor is just a curiosity. To be useful in court, our work must meet strict standards of admissibility. International standards. Phrase Standard 1923. Does the method have general acceptance in the scientific community? Still used for fingerprint and bite mark evidence in some Commonwealth countries. Liebert Standard 1993. A more modern approach. Courts evaluate whatever a method is testable. Peer review has known error rates and is accepted by experts. This is the global gold standard. Philippine legal framework. In the Philippines, 3 rules govern our work. 1. Rule 132 of the Rules of Court. Evidence must be relevant, relates to the case, material, matters to the outcome, and authentic is what it claims to be. Number 2. DOJ Circular Number 41, 2001 sets strict standard for lab accreditations and expert testimony. Our chemists must pass rigorous exam and maintain continuing education. Number 3. PNP Crime Laboratory Manual to 2020 defines every step we take from evidence collections to reporting to ensure consistency and reliability. For evidence to be admitted, we must prove 3 things beyond doubt. Validity. The method is scientifically sound like GCMS for drug analysis. Reliability. We follow every protocol with proper controls and checks. Authenticity. The sample we tested is the same one collected at the scene. Proven through chain of custody. In court, our job is not to impress with jargon, it's to explain complex chemistry in simple terms so judges and juries can make informed decisions.
Forensic chemistry analyzes 4 main categories of evidence, each with unique needs, especially here in the Philippines. Let's break them down with practical local examples. The first one is biological evidence, the human connection. Types are blood, saliva, semen, hair, and tissue samples. In preliminary tests, Kastle-Meyer turns pink because in the presence of hemoglobin or the blood. Fadibas turns blue when saliva is present. In our tropical climate, biological evidence degrades 2 to 3 times faster than in cooler regions. That's why PNP SOP or the Standard Operating Procedure 03-2020 requires us to add silica gel packets to paper bags because they absorb moisture without trapping heat like plastic does. We also transport samples in insulated coolers even for short trips across Davao Occidental. We use the phenyl chloroform method to extract DNA, then amplify specific regions using PCR. It is a process that can produce a profile from just a few cells. The second one is trace evidence, the tiny details that matter. Types are fibers, paint chips, glass fragments, soil, and gunshot residue or the GSR. In preliminary tests, burn tests to identify fiber type, the cotton melts differently than polyester. Microhardness tests to match glass from broken windows. Soil analysis is critical in our rural areas. We've built a database of soil compositions from over 50 barangays. Each has unique mineral mixes that let us pinpoint where a sample came from. Just last year, we matched soil from a suspect's boots to a specific farm in Barangay Pangyan, placing him at the crime scene. Polarized light microscopy for visual matching and FTIR spectroscopy to identify the chemical makeup of the fibers and paint. The third one is impression evidence, making the invisible to visible. Chemical enhancement methods. Ninhydrin reveals fingerprints on paper and cardboard. It produces a purple print. Superglue fuming. It works on a non-porous surfaces like metal and plastics. It creates white and 3D prints. Luminol detects blood traces even after cleaning. It glows bright blue under UV light. For remote crime scenes where commercial reagents are hard to get, we've developed a homemade alternatives. Our luminol substitutes uses common chemicals like hydrogen peroxide and sodium hydroxide. It's not as sensitive as commercial products, but it works when we need it most. The fourth one is chemical or toxicological evidence, identifying dangers. Types are illicit drugs, poisons, explosives, and arson accelerants. Preliminary test. Marquis reagent. It turns purple for opioids like morphine and heroin. Scott test. It turns blue for cocaine. Gas detector tubes. It identifies accelerants like gasoline or kerosene in seconds. Our region faces unique challenges. We frequently encounter homemade drugs and agricultural poisons like paraquat, which aren't always covered in standard training. Our lab has developed specific protocols for these substances, including rapid tests for paraquat that can save lives in poisoning cases. GCMS for drugs and accelerants, LCMS for poisons, and ion chromatography for explosive residues.
Chain of custody, proving the evidence is real. Even the most brilliant lab analysis means nothing if the court can trust that the evidence is exactly what we say it is. Arson case, charred wood from burned house. Arson is one of our most conflict cases. Accelerants like gasoline or kerosene evaporate fast, especially in our 30-degree heat. Here's how we protect this critical evidence. Packaging roll. Plastic containers absorb volatile chemicals. By the time the sample reaches the lab, we have nothing left to analyze. That's why we use heavy-duty metal canister with rubber gaskets. They lock in every trace of accelerant. Watch how the lid seals tight. You hear a distinct click when it's secure. Second is labeling beyond the basics. Along with all the standard case details, we add a bright red warning. Arson debris do not expose to heat. We also mark the exact spot where the wood was found. East bedroom window frame, Barangay Pangyan, because different areas of a fire can tell different stories. Third is sealing that can be fake. Commercial crime tools can be expensive, so we've adapted this homemade tool uses reinforced pliers and metal dies we had crafted at a local machine shop. When we crimp the seal, it bends the metal edge into a unique pattern that can be replicated without damaging the canister. Fourth is temperature logs. Our tropical safeguard on the chain of custody. We add a special section of temperature readings. We check and record the temperature inside our transport cooler every 30 minutes. it climbs above 20 degrees Celsius, we know we need to transfer the sample to a lab fridge immediately. Last year, this extra step saved evidence in a Malita case where the transport vehicle broke down in the sun. Drug case, simulated Shabu from bypass operation. Controlled substances require extra security, not just to protect evidence but to keep our community safe. First, we follow Dangerous Drug Board Regulation number 1, 2021 to the letter. First is packaging design for safety security. We use vials with dual protection, child-resistant caps to prevent accidental exposure, and a tamper-evident band that breaks if the vial is open. You can see how the band fits tightly around the cap. Once it's on, there's no way to remove it without leaving visible damage. Second is labeling that leaves no room for doubt. Along with case details, the label features bold red text, danger controlled substance, PNP regulated. We also include the bypass operation number, the names of the two witnesses present during seizure, and the exact location where the exchange took place. Two witnesses everywhere, every time. Per DDB rules, every single transfer or drug evidence must be witnesses by two unrelated parties. They sign the chain of custody from alongside the handler. This could be a barangay official, a media representative, or a neutral civilian. Their presence ensures transparency from scene to court. Traditional meets modernity. The wax seal. While we use all the latest technology, we still rely on a Filipino traditions that's been used for centuries. Wax sealing. We heat colored wax. Each investigator has their own unique color, and press our initial into it while it's soft. Once hardened, this seal can't be removed or replaced without breaking, and the unique initial make forgery impossible.
Your role in the search for truth. Let me leave you with something that goes beyond protocols and procedures, something that defines why we do this work. The chain of custody is more than just a paperwork. It's your personal testimony to the court that the evidence you've collected is the same evidence we analyze. Every signature you write, every time stamp you record, every seal you apply is a promise. This evidence is real, and it has not been touched by anyone who should not have handled it. A single mistake, a missing signature, a mislabeled container, a broken seal can unravel an entire case. It can mean a guilty person walks free to harm others, or an innocent person is locked away for a crime that they did not commit. That's not hyperbole. We've seen it happen, and it's why we follow these steps with such care. Forensic chemistry in our country has come an incredible distance. We've started with vegetable dyes and basic glassware. Today's our labs are ISO accredited, using the same technology as the FBI and Scotland Yard. We've adapted global methods to our local needs, creating homemade tools, building databases of Philippine soil and fibers, and developing tests for substance unique to our region. But theirs hasn't changed. Our mission, we use science to deliver justice, not just for individual victims, but for entire communities. Every drug we identify keeps dangerous substance of our streets. Every accelerant we trace stops arsonists from destroying homes. Every trace we match brings closer to families who've lost loved ones. As new criminal investigator, you are the first link in the chain of evidence. You're the one who will be at the crime scene, in the rain or under the scrolling sun, making decisions that will shape the entire case. Learn these protocols, practice them until they become second nature, but never let the paperwork make you forget the people behind each case. Essential reminders. History teaches us to build an unproven methods that March test still inform how we detect prison. Lockhart Lab still shape how we organize our works. Lockhart's principle is universal, whether in Manila or Malita. Every contact leaves a trace. Legal administrability depends on progress. Following the rules, and your evidence will stand strong. Evidence category requires a specific care. One size does not fit all. Change of custody is non-negotiable. Protect it like you're protecting justice itself. Edmond Lockhart says it best, every contact leaves a trace. It's our job to find those traces, protect them, and use them to prove what really happened. You are joining a profession that serves as the backbone of our justice system. The work is hard, the standards are high, and the responsibility is great, but there is no more important work we can do for our communities here in Malita, Davao Occidental, or even across the Philippines. Protect it, prove it, pursue justice.